learn something new, I love to share. And this particular project we're looking at today has a little bit of everything in it. So there's a lot of stuff in here. There's some soldering, there's some Python, some PL SQL, little tiny bit, Oracle Jet, ORDS, all kinds of stuff. So I don't expect everyone to learn everything about all of these technologies. It's more meant of, here's a taste of a bunch of cool things. So kind of just sit back and enjoy the ride on that. If you check out my Twitter feed here in about 2 or 3 minutes, a tweet's going to go out with a link that will show you the final graph that we'll be building and the data that is flowing from my Raspberry Pi. This really is just a Raspberry Pi with a screen on it, nothing else fancy. So check that out and it will take you to that page. Last time I tried that in Glock, I was running it off the Raspberry Pi and I DDoS'd myself. So I moved that up to my blog. Another thing is I tend to be easily distracted by shiny things. My oldest son calls this ADOS, which is attention deficit. Ooh, shiny. I try to stay focused, but sometimes I get a little bit distracted. One shiny thing that's got my attention lately is my power bill. It just keeps going up and up and up, and I would kind of like to get that reined in. This is partially a green thing. You know, I'm all for making the planet more comfortable for all of us, but to be perfectly honest, I just really hate giving money to the local power monopoly. And since I can't shop around for better rates from other power companies, I need to learn how to use less energy. And of course, to do that, I need to figure out how much energy my devices are actually using so I can either replace or reduce the high usage items. A great tool for that is this little thing over here called a kilowatt. You can see it plugged in right there. You plug this into power, you plug something into it, and it tracks on this little screen here, it tracks how much power you're using, and you can display watts or volts or amps or, oh, my phone's getting on me, plug that in. Start charging my phone up there. And it'll display it on that little screen right there, and so you can keep track of how much power your devices are using. You would probably be surprised at how much power your devices still use even when you think they're turned off. Basically, if they're plugged in, they're consuming some amount of power, some more than other, and a lot of these IoT devices, not only you turn them off and not only are they still doing stuff, but they're sending stuff up to the server. So some of them can take a lot of power. And of course, I plug that in, I get going, and I want to track my data. Being easily distracted, I'll probably come back a month or two from now and wonder what happened to all of that data that's going into that little device there because I wasn't paying attention. So being a database guy, I would like to keep track of my data a little better than that. I could do pen and paper. I guarantee I would diligently track records on that paper for probably maybe 5 records if I'm lucky. I doubt I would ever even see the 5th entry. So it's probably not the way for me. I could write a cell phone app. That could be kind of cool. I could take my cell phone and every now and then come take a picture of the screen and OCR that number and push that up to a database. But then how do I access the camera? Maybe I could look at a barcode app and see how they do it. But you know, if I'm doing a barcode app, you know what would be cool is I could get in my pantry and scan all the barcodes on my groceries, and I could write an app to track my grocery list. And like I said, ooh, shiny. And every time I go into a cell phone app, I get like a dozen cell phone apps going. So rather than going down that rabbit hole and building multiple cell phone apps, why don't we try and keep it simple and instead we void a warranty? Did I mention I like to take things apart? So fortunately for us, Lady Ada, I believe is how you pronounce it, has put together this project called Tweet a Watt, and you can find it on that URL there. The slides are available up at Kscope, and when you're done, it will look like that. I have these parts. Here is the tracker, and here is the little cable that's receiving the signal. What it does is you take these little XB radios that if you come up closer, you can see one close, but there's one of these there and the other one is soldered inside of the device to the chip in there. The project comes with everything you need. It's got great instructions on how to build it, but what it does is it will tweet out your power usage every 5 minutes. So, you know, unless you want to really annoy your Twitter followers, that might not be the best thing to do. I'm going to convert that to put the data into a database instead. So these XB modules, the transmitter and receiver, they do require a little adapter board. So that's the part with the flashy lights that the wire's plugged into, if you can see that. And that will require just a little bit of soldering. I'm sure you could probably find someone selling these boards pre-assembled if you really don't want to solder, but hey, that's no fun. How do you get burnt if you don't try and solder? On the Adafruit site, there is a guide just for these boards, and it's a really good guide. It has some really good tips that save me some trouble, such as when you're putting the components into the board, don't clip the wires. Put the wires all the way through and bend them so it holds your component in position. Then solder it, and then clip the wires. That probably saved me having to buy a few new extra resistors. If I can give you a tip, it's get some decent tools. The better your tools are, the better time you're going to have soldering stuff together. This is a board clamp that I got off Amazon. It's just a little spring-loaded. You put the board in there, holds it in place, so you can have a hand free. Speaking of extra hands, this is called a helping hands, and these little clips are adjustable so you can hold your resistors in place, and then you have just soldering iron in your hand. I wasn't real happy with this particular one. This base looks like it's cast iron, and you think, oh, that's heavy, but it's really, really light, and I pretty much had to just prop stuff up on the bottom to hold it in place or it would tip over. So more than likely I'll be taking that apart and putting something heavier on the bottom, or even screw it into the desk if I get around to that part. But it still worked, and as you're getting older like me, the magnifying glass is very handy. Now this next part is going to be a quick slideshow. I know we all love looking at everybody else's pictures, but on the left will be my awesome soldering job that I did, and on the right will be the way it's supposed to be from the project. So I'm doing this because if you're a little hesitant about trying out this project or a similar project because you don't want to try and solder, it's not as hard as you think it is. Just give it a try, and even with the mistakes I made in this project, it still works. And that's my goal, is it works. So we'll kind of go through this one a little bit quickly. First up, we build the receiver board. That's actually the board that's out on the table right there. We solder in a couple LEDs and some resistors to power to regulate the LEDs. Flip the board around. We solder in the capacitors and power regulators. And then we flip it back up and we put in the buffer chip. Now on the buffer chip, you'll notice that there's a little U-shaped cutout here and a dot here. The U goes towards the lights. It does fit either way. I'm not sure what happens if you put it in backwards. I did go slow on this step and make sure I got that right. I doubt if that would cause any smoke, but you never know. My first major mistake here. I soldered on these things, they're called the headers. This right here, this is what the board plugs into so the board can come out. The tip for that is to put the headers on the XB unit first, sit that in the board, solder a couple points on the headers to hold them in place, take the board back out. Because if you don't take the board back out, what my mistake was, you see the gap there, when I soldered in this pin, I put too much solder on it and it flowed up into the hole. Had I not taken the board out, it would look nice, but it'd be permanent. So to fix that, I took my vice grips and put a pin in the vice grips, pushed down in the hole, heated up the solder, pushed it back through. It's still not perfect. If you come look at it, there's still a little bit of a gap, but hey, it works, and that's what I'm going for. All right, to finish up the receiver board, we solder on the bottom header strip. You'll notice my pins are not all nice and even. That is not the screen. That is my awesome job. And you probably can see right here where it looks like the board is burnt. That's where I was fixing the header strip. Even though the board is burnt, it still works. It's a very durable project. And then you can see here where I didn't put enough solder on a couple points. Even in that state, it worked. Like I said, very fault tolerable. Is that the way to say that? I did go back and put a little more solder on those because it was a little too ugly even for my taste. But with that, we put the board together, and it's time to program the XB units. You download this piece of software called X-CTU. You get it from digi.com. That's the people who make the XB units. And with that, you'll upgrade the firmware, and you'll configure both of your units using this receiver board. One you're going to set to be a transmitter. It sends out the usage every couple seconds. The other one will be the receiver. That's the one on the table. The project goes into great detail on how to set that up, and it'll be a little different depending on your operating system. So read the instructions for that part. Tip here, make sure when you program your two boards, mark them or keep them separate. Otherwise, you wind up screwing the receiver inside of the device. It's not hard to get it back out, but it's not fun to take things apart for no reason if you just fixing a mistake. All right, time to put together the transmitter adapter board. This is going to be a little bit different because the transmitter is actually siphoning power off of the kilowatt unit. And so we don't use all of the parts that came with the kit and add a couple extra things. You'll notice this giant capacitor. It's about the same size as that board. Mistake I made here. I ordered my ribbon cable and I got the gray one. There are a few wires in there and not enough to where I probably would have lost track too much, but what I did was I took colored Sharpies and colored my own. Get the rainbow cable if you're going to do the project. It makes it a little bit easier. All right, quickly through this part. First up, we put the capacitors and power regulator on the one end of the board, same as before. This board, we're only using one LED, and you can see it poking out here, but unless you're looking straight down, you probably cannot see that it's flashing every couple seconds. That's because I used an LED from my Raspberry Pi kit, and I used the wrong resistor, so I'm over-regulating the power, so it's not very bright. But it is flashing if you want to come up and look straight down the hole. I don't know if you noticed that it's about an inch out and it's bent at a 90-degree angle so it can fit out of the hole. And then here we put on the headers. This is what they look like from the top view. Same as before. I learned my lesson last time, so this one actually worked. This part looks hard. It's not nearly as hard as it looks. There are a couple spots where it looks like the resistors are going through the same hole, but the hole's not big enough to get two wires through. So you solder one wire into the hole, and then you solder the other wire piggyback on there, and that's where those little helping hands come in really useful. And also notice that my wonderful color-coded wires, can't really see it in the picture. All right, so from here we put on the reset capacitor. I'm not exactly sure what it does. It involves the word reset, but the schematic is available if any of you are electrical engineers and want to see what all this is. It's in the project. But you'll notice that this is large enough that if we had just put it straight in the board, the XB unit wouldn't be able to snap on, so you have to bend it down at a 90-degree angle and have it poke out of the bottom of the board. Put that all into place before you solder it, save you some desoldering. Like I said, we're going to siphon power from the unit itself, so we need to regulate that power. We don't want to just send 120 volts through our little tiny radio. So this is where that giant capacitor comes in to play, and a little diode. Notice the diode has a little gray stripe telling you which way the power is flowing. Not sure what happens if you put it backwards, but on this one I would bet on smoke. So pay attention to where the stripe is and make sure it goes in the correct direction. All right, so that's what the transmitter unit looks like when it's fully assembled, the good and mine. And we're ready to crack open the kilowatt, and oh crap, mine does not look like theirs. This was my first major panic moment. I'd already had my presentation accepted, and I was like, uh-oh, this doesn't work. There are 3 or 4 models of kilowatt out there. And fortunately, I take the board that's on the other side off, flip it over, and it's kind of similar. The chip that I'm looking for is this little tiny one here rather than the big one there, and you'll notice mine is smaller. And unfortunately, this model, the pins are not even marked. However, jump on DuckDuckGo. This project is like 7 years old. Somebody else had this exact same model, and they provided the pinouts. The magnifying glass comes in really handy because these are very small pins, and even though it looks like these two are touching, check with your multimeter to make sure you didn't make a mistake. We are working with power here. Put that back together, flip it over, mount the capacitor and the unit inside. Use the double-sided mounting tape. You can get it in the paint section of your hardware store. Stick it in the case. This is just before I drilled the hole to put the LED through. Then screw everything together, plug that piece into your computer and the power unit into some power, and turn back on the X-CTU serial console this time. And all this red stuff, it's not blurry, it's really just gobbledygook. It will change every couple seconds. If everything's working, that means power or information is flowing. We don't really need to know what that means. If you're curious, I'm sure we can figure it out. But now that we have data flowing, being the database guy that I am, I want to persist my data. So the project comes with some Python modules pre-built. Everything is fully functional at this point. If you just take their stuff and run it, it should be working. But I don't want to tweet my data. I would rather put it into my database. So I could modify the Python modules and just do insert statements, but then I got to consider database users, security, ports, all that kind of stuff. And we've probably all done that at least once. That's not fun. How about instead we just use REST? Of course, if you've built REST services before, you're thinking, well, now I need to stand up a Node server or a Java server, some other server, and build a whole REST API, and I still have to do the insert statements anyway and deal with all the ports and users. Well, I'm sure you've heard about ORDS by now, but we have Oracle REST Data Services. ORDS is included with both the Oracle Database and Oracle SQL Developer installs. So if you're looking to get that set up, that's where you can find it. And from here, rather than, I actually have the long URL there. I believe it's just /rest now to get to ORDS. So ignore that and type REST and you'll get there faster. All right, so this is where I break my slides every time, but that's okay. I know what I'm doing. I'm a professional. All right. I am a little cut off there. So to set up ORDS. So what I'm going to do at this point is I'm using SQL Developer. I'm on 4.2. something something. I have already pre-built this, and that's what's running when you see the stuff flowing on the Raspberry Pi. And but I'm going to rebuild this right here. So first step, right-click on your schema and connect. Once you are connected, you need to REST enable your schema. So you right-click on there, you come down to REST services, and you click enable REST service. You can see that there. So let me turn that on. All right, mine is already enabled. If it were not, this would be unchecked. So you check this box. You probably want to put security on your stuff, just a demo, so I'm going to leave that unchecked. And then you give it a schema alias. You need to remember what the schema alias is. We will need this later. We click next, and we get a little summary of what's going on. And I'm going to hit cancel because I'm already enabled. You would just hit finish and get the same results. All right, from there are a couple different options to create your REST services. If you're a hardcore command line, you can just start typing in SQL if you know what to type to put it in the database. You could use the REST development panel over here, but I'm going to use inside of the same connection. You'll find these REST data services here, and I'm going to create a new REST module. Think of a module as a collection of similar REST services. So if we put this into schema table type of a mindset, your module would be HR and your REST services would be like people and departments. So I'm going to right click on module, I'm going to click new module, and I'm going to give it a name. The name doesn't matter. I'm just going to call mine power. Don't even care about the misspelling. This part does matter. This is part of the URI that you're building out, that your other applications are going to consume this URI. So I'm going to move my cursor. Notice right there as I type that it fills out the URI for you. Remember when I said, remember this word? That's where that goes there. That's actually part of your URI. This part you will get from your system admin. That's the URI to get to the ORDS server. So with that set up there, I want to publish this because I want to use it. I will come back to pagination size here in a second. We click next. Now at this point we're down to, in the schema thinking, we're down to the people or departments level. So this is going to be my actual REST endpoint. And I'm going to call mine usage because I'm creative like that. Did I spell that right? Usage. Okay. And that's it. You'll notice that it also expanded the URI there as well. We hit next. We get a little summary of everything that we did. If you'd like to learn how the SQL works, you can click on the SQL tab and go through that. But I'm just going to hit finish, and it has successfully created my REST service. Now, you'll see I already have this one down here built, so if everything goes smoky, then we can take a look at that. But inside of our Power module, we have our usage REST service right there. Now we need to handle our REST calls. The REST calls come in, you can do get data from the service. You can do post, which is, here's a new record and I don't know what the ID is supposed to be, so that's a post. You can do put. Put is replace an entire record knowing the ID. It's not exactly the same way you'd think of an update where you update specific columns. It replaces the entire record. So keep that in mind when you use a put. And then of course delete, here's the ID, get rid of the record. I am going to add a handler, so I right clicked on that. You can add one of each of these. I'm going to add a get, and I'm going to base it just on a SQL query. I would like my data to come back in JSON format, so I'm going to leave it as JSON. And I'm going to set my page size to 10. So if you have 1 billion records in your database and you put a REST service on top of that and somebody does a get, that's going to take a long time and something's probably going to crash before you get to the end. So pagination is a good thing. That's one of the things I like most about ORDS is that extra functionality that is pretty common standard throughout all REST services is built in. You just mark that as pagination and it will handle the extra links, and we'll take a look at those here in a second. Now, since this is not a demonstration of how wonderfully Blaine types, I pre-wrote my query here. I'm just going to copy it from there and paste it in. You can see it is a pretty simple query. I'm just getting the data from the table. I'm only checking for sensor ID of 1 since I have one sensor, and I'm looking for the records in the last 10 minutes. So there's my timestamp with the minus the interval, and then order by create on. When I hit save here, that just pushed that new REST service up to ORDS. It's live, it's ready to go. You can pull data from that now. However, I also want to be able to get data up to it, so I'm going to right click once again on usage. I'm going to hit handlers and I'm going to add a post. Now with post, I'm going to be sending data into my service from somewhere else. And so my server needs to know what format that data is coming in, and so that's what the MIME type is. This has nothing to do with those weirdly dressed guys in France that can't get out of the box. But I'm going to make mine JSON because I like JSON. I have a cousin named Jason. He spells it different. So I'm just going to put application JSON in the MIME type and hit apply. With that, I have the post service ready to go. I need to add some code so that we know what to do with the data when it comes in. For the operations that modify data, put, post, and delete, we use PL SQL. It gives us a bit more control over what's going on, and some, we can do anything you want to do with PL SQL, you can do in here. So you can make this as complex as you would like. Mine is fairly simple. It is just an insert statement that says insert into power usage. The values are bind variables. If you went to the database thing yesterday, you will know bind variables are very important. Just ask Chris over there. Our bind variables, our first two are sensor ID and watt. Another really nice feature of ORDS, if your data coming in matches the bind variables, the keys, you don't have to map them. So if mine is sensor underscore ID, I would have to map it. But as long as the data matches up, ORDS figures it out for you and saves you some work. Now, when I do an insert, I think it's proper practice to return the new ID that I just generated. So I'm going to return the ID into new ID, which is all this variable is up here, and then I'm going to assign that new ID to, I should probably name that something different so it's less confusing, but I'm going to assign that to a bind variable called new ID. And I also think that when we are doing REST services, if something works, so if I send a command that works, the status should come back as 200. Yay, it worked. 201 means yay, it worked, and I created a record. So it's a little bit more information for the whoever's consuming your REST service. So I'm going to set my status to 201. But right now, neither of these bind variables mean anything to ORDS. So I do need to map these two because I just created these. And in order to map these, we go up here to this parameters tab. And we add a bind variable. So with ORDS, as with Apex, there are some predefined parameters. I'm not sure what the official name is. It says parameters in my notes, so I'm just going to call it a parameter. This particular one, X-Apex status code, is one you can use to set the status code of your response back to whoever called your function. And so the name side is what Apex will use, or ORDS will use. The bind parameter side is what you will use inside of your PL SQL. And so I will go back into my SQL and grab, I could have just typed status, but my typing is awesome. I'll put that there. This is going to be an out parameter. I'm sending this back as part of the response. The status code does go in the header, so I will leave that the same, and it's going to be a string, just because I'm lazy and I don't feel like changing it. I will hit plus, because we're going to now also map our new ID. I could have copied this from here or from over there, but if you remember, the names were both the same. Now this is returning our new ID, so it's also an out parameter, and the source type is response, because this information is going to go in the body of the response back to the client. And we'll leave that as a string as well. You can look at the details tab to see that we have added power and usage as our REST service. Remember, I called it kilowatt demo, COD demo. That part would go under my schema, and this part you would get from your admin. So I'm going to go back to here and hit save, and watch over here as my post magically appears. So now I have built a REST service that accepts post data and returns get data, and it all works. You can trust me on that. Don't trust me on that. Never trust. Verify. So let's switch over and look at, right here I'm using a tool called Boomerang. It's a free Chrome plugin. I also use another one called Arc, which is Advanced REST Client. They both have their pluses and minuses. I never settle on tools, so today I'm playing with Boomerang. So first up, I'm going to do a call to, I've got the wrong one in there. Remember, I called it power usage. And then the rest of the URL was the one that I received from my admin. So I'm going to send a get to, that sounds weird, send a get. I'm going to send a get command to our new REST service, and you'll see here that we have an array called items. That means it's an array, and we have our 10 items with all of the data that I selected. Now, when I had mentioned the pagination built-in functionality earlier, this is what I was talking about with the included links. ORDS built these for me. I didn't do, there was no sleight of hand. I didn't do anything extra to make this happen. When you're paginating your data, you get your response back, you take your items out, you do what you want to do with them, you check this object to see if there is a next. If there is a next, then that means you have more data waiting on the server. Then you get the ref from the next, which is the URL for the next page. So if I carefully copy that without the quotes, for some reason my browser doesn't like extra characters in the URIs, and I will paste that in there. It basically just says page 1. I hit my send, and I get the next 10 items, and now I also get a previous. So that tells me I'm no longer on the first page, I'm on the next page. I also have another next, which means there is more data, and so in your application consuming your REST service, you would just keep looping through that pattern until there's no more next. I'm going to jump all the way to somewhere where I know there are no more nexts. I will not get any data at this point. Pretend there are items there. On the last page, you'll see there's just a first and a previous. So rather than page through, I have data constantly feeding in from there. That's why I don't know where the last page is at the moment.
So the previous with the 999, but that's not real either, is it?
That is the previous page, but you're going to get nothing there. Yeah, it doesn't check to see where the last data was. It checks to see what the previous page was. So if you cheat like I did, then you're going to get cheater information back. If you, this part is all built so that a computer can browse your REST service the same way you would browse a web page. So you go to a web page, you see a link, you click it. Your computer goes to a REST service, it looks for a specific tag and gets the value from there and follows it. So your computer's not going to guess, unless you wrote your code wrong, what the next one is, and it could have looped through a lot faster than I did. So our get is working, but one thing I want to change while we're still on get is I'm going to go back to my get. I'm going to go into the details tab, and remember the pagination size. I'm going to set this to 0. I know that I'm sending a record every 10 seconds, and in my query, I'm only querying the last 10 minutes worth of data. Should be 60 records, give or take, lag in the signal. I think we can handle 60 records. So I'm going to set that to 0, and I'm going to resave that, and then we'll come back over here and just take off that page at the end, and when we send this, we get all of the records for the last 10 minutes that we have created. And notice I'm at the bottom. If you can hear the wheel still scrolling, there is no first, next, previous because I got all of the records. Those things are not needed. All right, so that's the get. On the post, this is what you would do in your other application that's consuming your new REST service. We have a JSON object here that is just sensor ID. Notice this sensor ID key matches that bind variable, so I didn't need to map them. And then we have what also matches. And then in the headers, we have our MIME type of application JSON also matches. So that gets our data up to the server. When I hit send, it comes back and notice my little 201. Yay, it worked, and I created a record. And over here, we have, I got the right finger, we have our new ID of 11401. If I send that again, we get 11403 because while I'm sending from my tool, my little firestorm over here is potential is still sending data every time that light flashes in the background. All right, so our post is now working. So let's see if I can get back to my slides without breaking everything. This would be a first if this happens. No, I don't want to close that. I want... And of course it didn't work. All right, so let's go back to here. Okay, all right, back to there. So what did we just do? We created a REST API from scratch. We enabled the REST service. We enabled REST services for a schema. We found the table that we were going to, I guess I skipped that part. I already had a table made, so that's kind of the boring part. Sometimes I forget to do that. But you pick the table you're going to use or you create a table. We created an ORDS module. That was an interesting part. We added the resource template URI is, I believe, the correct way to say that. That was, so HR, the resource template URI would be the people or the departments. And then we defined resource handlers for get and for post. And then we tested all of that out. And with all of my blah, blah, blah around that, that took about 10 to 15 minutes to create a full REST service from scratch. Without all of my blah, 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 ignoring how complicated you want to make your PL SQL, that's up to you. But all of the rest of it, you can get down to where it takes maybe a minute, 2 minutes tops to create a fully functioning REST service that handles all four of the handlers. So quick, easy, a lot better than standing up some other server in Node or Python or whatever. That can be fun too, but if you're going for quick and easy, this is the way to go. All right, so from there, we now have our REST service up and waiting to be consumed. We need to consume that. I believe that's the correct way to talk about that. The Tweetawatt project comes with some Python code. That it would be in this Tweetawatt master zip. And in there are a bunch of files that do all kinds of things. We are concerned with 3 files. The first one up is sensorhistory.py. This one runs the timers for the calculations, keeps track of the data from the sensors from the XB, and with that it calculates the kilowatts per hour for your time slice that you're tracking. And you will see in there, if you look at the Python code, littered throughout there. It will say 5-minute timer or 5-minute list. From all of the testing that I can find, knock on wood, the 5 minutes is just a label. I have monkeyed with this for days, and it seems to work with whatever time slice I put in, and we'll look at the time slice here in a second. We also need the xb.py. This is the one that takes the data that comes in through this little thingy into the computer. And by the way, all this Python stuff is running on my Raspberry Pi, not on my laptop. But it takes all the data that's coming in through there and converts it into something useful and sends it, and then we use that in the next one. There was, so it collects data, formats the data, and so the next one is watcher.py. Notice the clever double T for watcher.py. In here is the code if you would rather just write this out to a CSV file. That's included. The Twitter interface and the graph, the data using a Python graph. I'm not planning to use any of their code for that, so I created my own watcher-min that strips some of that out, and we'll take a look at that in a minute. Some of the more advanced versions of Watcher, they have like 5 or 6 different versions in the project. One has code for interfacing with the Google App Engine if you'd rather do a Google app. One has code for how to run multiple kilowatts. So if you were actually going to do this in your house to track your usage, you could have one receiver and just build a bunch of these, put them throughout the house, and modify the code so that they all consume the same REST service. That goes back to why I'm tracking that sensor ID. Not really using it, so I could have left that out, but look at the advanced code for that. Now, I'm more familiar with Python 3 than I am with Python 2. So I ran these 3 applications through Python's 2 to 3 converter. I have to say that slower, I get too many 2's in there. And when I did that, I only got one error that we'll look at in a second. I did make a couple other modifications to these just because I have my little coding idiosyncrasies. I'm old, I like to do things a certain way. I'm also running this project on both my Windows 7 laptop and my Fedora box at home. And I don't remember which one was which, but in one of them, this value for P comes in as a string, and it doesn't come in as a string in the other one. And that causes a problem, so we changed line 27 to check to see if it's a string, and then run it through the ORDS. I don't remember what that actually does. It converts it to like a binary or something, I don't know. I didn't care to know. This fixed that problem. If you're only running it on one or the other, you don't really need to do that if yours works. Like I said, I created a thing called watcher-min where I stripped out the code for the tweeting, for the graphing, for the Google code, all the stuff that I don't intend to use. That's just extra things that might cause a bug for me, so I strip all that out and I make one called watcher-min. I am a believer that if I write code and that code behaves differently based on the environment that it's running in, then those settings should be based on environment variables. So I changed these 2 lines to read environment variables rather than having a bunch of if Linux, if Windows statements in there. This was the line that threw the bug when I did the 2 to 3 conversion. I don't remember what the bad line looks like, but this is the good line. It was something with the quotes messed up the print statement, but that was the only error that I got for the conversion. Here is the line that I talked about, that changing the time slice. Originally they had it checking to see if the time was greater than 60 seconds. Then they would do a mod to see if it had been 5 minutes. Yeah, that could be written a whole lot better, but I only wanted 10 seconds anyway, so I changed the 60 to a 10. I got rid of this. That's good enough. That works. So we're going to be doing 10-second slices. And then this is one of those little things that bothers me. They had called this function, stored its value, and then used the value somewhere in between these 2 lines. But the value doesn't change until it cycles through again anyway. But they were calling the function in multiple places, so I replaced the function calls with that. Once again, my little hang-ups. If you don't care, if you don't convert from 2 to 3 and you are fine with 5 minutes and you don't care about any of my other things, you can ignore this whole slide. It just works. But this is me. All right, with that running, you run it by typing in Python 3 watcher-min. And if you just type in watcher-min, then you'll see data scrolling like this. You don't really need to read the stuff, you'll just see it cycling through. If you add the -D, it puts it in debug mode, and instead it will look like this. Gives you a whole bunch of data, and I'm sure it means something. The only thing that I actually care about is this one line where it says AMP data. You'll notice we have a 493 and a whole bunch of 492s. If it were perfect, those would all be 492s. There's a little spike there. It could be because the XB draws some power off of the unit. It could be because it's an older unit. More than likely, it has something to do with the awesome soldering job that went into that project. But you pick either the average of that line or the most common number, and you modify the line that says calibration for sensor 1, put it there, and that will get it pretty close. If you check the Twitter feed and you're watching the graph, you'll see it's got a bunch of little, my computer's getting low here, let's plug the computer in. You'll notice that it's got a bunch of little spikies in the data. That's because of, probably like I said, the soldering job. But all I'm looking for is highs and lows, so good enough. All right. So from there, one more thing that I like to do. I like to have control over things. So I added a command line. Oh, no, I'm skipping ahead. So this is the function that calls our ORDS application. So I added this Python module. I simply imported the Python request module, made a function, defined the URI and the data, did a try of to post the data using that stuff up there. I put a 2-second timeout on it. If the data comes back within 2 seconds, then I created the new ID and the new ID that came back. If it doesn't, I don't care. It didn't crash. It's taking too long. I don't care. I'm moving on. So, like I said, I'm aiming for it works. All right, so back to the control obsession that I have. This is simply adding in, checking for a command line argument of -O. So when you run this and you give it a -D, you get that big chunk of data. If you give it a -O, then it looks like that, but every 10 seconds you get the ID printed out on the screen. If you don't care about adding the control, this line here is the only one you care about. This one goes inside of that if statement with the 10-second timer that I was talking about. All right, so with that, we have our hardware is still functioning. We have our REST service up and running. We've tested that out. We now have our Python application, which I have running on the Raspberry Pi, pushing data up. It's time to get the data back, and let's try and make this pretty. So I'm going to show you a quick demo on Oracle Jet. Oracle Jet is Oracle Jet is Oracle's JavaScript framework, and it is fully open source, and it's got a lot of cool features in there. What we've done is we've taken a bunch of other open source projects, mixed them together. So there's Knockout.js. If you're writing a web page and you have some JavaScript and you have some HTML, you can write a lot of code and tie that together. So when things change over here, things change over there. Or you can use something like Knockout.js and just make the call. So that's included in there to do the dynamic binding of the data. There's Require.js, which handles the dependency injection, a whole bunch of stuff. If you'd like to know more about that, I'm happy to ramble on and on afterwards. But rather than do that, why don't we actually go take a look. So once again, let's see if I can break my projector. And flashy, flashy. Before we get started, I'm going to, this looks like I'm cheating, but I will explain this when I get back to it. Let me just make sure that's running. Okay, that's running. And Oracle Jet. So this is the graph that you would see if you went to the web page that's on my Twitter feed. All right, so Oracle Jet, this is the home page for Oracle Jet. A lot of what is it and can explain stuff a lot better than I will. I click on the Get Started tab, which takes us to here. There are multiple ways to get started with Oracle Jet. Oracle Jet does have a Yeoman generator, if you're familiar with the whole node development process. If you'd rather not use a little bit of node in Yeoman, you can download this zip file that is linked right here and manually put it in your project. I am going to go through and use the Yeoman generator. I have already done the NPM installs because that is really unimpressive to watch. And then the command that I just fired off in the other window is this let me make that bigger. Yo is Yeoman. Oracle Jet is telling it which template I want to use to generate an entire project. I gave it a project name of Track-A-Watt, and then I told it I want to use the template of Nav Drawer. The reason that I fired that off in this other window, and it's still running, I'm better at the Linux command line than I am with Windows stuff, mostly because it works. But in my Windows machine, I use git bash to do all my command line stuff so I can still have the Linux calls. However, like I said, I take things apart all the time, and somewhere I have something not quite catching. So if I try and run an npm call with a bower call, it doesn't end well. So that's why I ran this one in the Windows command line. Otherwise, it would have looked just the same. Oh, good, I timed my blah, blah, blah just right. So you can see here a summary of everything that Yeoman did with that template. It downloaded a bunch of stuff, put it where it goes. We can look more detailed into this if you'd like later, but just know that it built us a project from scratch. So if we jump back over to Atom and we look here, this is the directory that it just created. It added in all the Bower components, nodes, some scripts. It uses Grunt for the build tool, and it pre-built the Grunt build files. So once we have that built, I'm going to open a terminal down here. The first thing, of course, we do is we go into the new directory and we do a grunt build. Grunt build is going to collect just the pieces that you want to deploy and put them off into a place to deploy them with. And that's why this web directory just popped up here. If you were to deploy this project, you only need to deploy what's in here. You don't have to do the whole thing with all the Bower and stuff. With that going, I'm going to make sure I'm back up here, and I'm going to fire off grunt serve. This is built in with the Jet generator. It's got a thing that fires off a node server and serves up your new Jet application. And once that's done, hands off, it opens the browser tab for you and points you to it. And this is the blank, clean Jet application you get from scratch. Usually when I'm building a project, I do this, and then I change the code that came with it. It's a whole lot better than typing for days. It has 4 different tabs here, and they pretty much all say put something here. I'm going to hijack the dashboard tab and add a graph. So let's jump back over here. I'm going to minimize that because that's not really fun to watch. And then I'm going to, actually, before I do that, that gets us to this step. Now, to get a graph, I could go out and write a whole bunch of CSS and HTML and a bunch of boring stuff, or I could use the Oracle Jet Cookbook. The Cookbook is one of my favorite things I've found recently. This has a whole bunch of pre-built, nice, pretty functioning components. If you're doing data grids or list views or tree views, you want some fancy controls in your application, there's a progress bar, you want your forms to be pretty, you do that. Frameworks, layouts. I want a visualization, so I want a chart. So I scroll down till I find chart, and the chart that I want is called the line area chart. So I click through there, and here you have a fully functioning working chart that you can see, and that's kind of impressive until you realize that if you look down here and you look at the info tab will tell you more about it, but the fun part is like you look at the JS tab. Notice the first point here is 74. I'm going to change that to be 24, and I hit apply, and it live rebuilds the page. So you can look at the code, both the JavaScript and the HTML, mess with it. If you break it, because I never break anything, hit refresh, and it resets it back to scratch. Once you've got, you're comfortable with it and you want to use this, you can copy and paste directly out of the cookbook into your application to get the working components. Now, this does have these extra buttons down here, and it's got the 2 series things. I don't really care about all of that for this demo. I just want the graph. So I'm going to cherry pick just the components I want because, yes, we can do that as well. I do need the dependency of the OJ chart. So first up, I'm going to copy that. And then back in my newly generated application, I'm going to expand the source directory, the JS directory, the view models directory, and the views directory. Inside of view models, I'm going to open dashboard.js. It comes pre-built with a bunch of JavaScript code in here that's used for stubbing things in. if you want to do that functionality. I don't care. I'm just going to push all that stuff off the screen. I'm going to add in that dependency. This is where, if you're going to use certain components, you have to put that dependency in this define array. Since I'm using the charts, that goes in there. I already have jQuery defined up here, and Knockout, and of course the core modules for Oracle Jet. From there, I'll go back over to the cookbook, and really all I care about are these two Knockout observables. They call them observables. That was, remember I was talking about binding the HTML to the JavaScript. The Knockout observable is the object that makes the magic happen. These two happen to be observable arrays. I'm not going to pre-populate my data, so I'm going to take that out. I believe these should both say self instead of this. If I'm going to define a self, I should use a self. So I make those changes, and now it's that's all I really need from the example. Now I do need a function that will call and consume my get ORDS service that we created before. And once again, you don't want to watch me type forever, so I'm going to cheat and just copy and paste in my pre-built function. Looks fancy, it's almost this long. Really, it's very simple. It's just a standard jQuery AJAX call. It's a type of get, because we're going to get the data down from the service. I have pre-entered our URI here to go to the one that we just created. That one says power usage. The one that I had pre-built, just in case everything goes wrong, is CAW usage, so it is different. I'm not cheating that much. Down here, remember I talked about your items come back in that items array. I don't care about everything else. I just want the items array, so I take that array out and I drop it in my own variable here for response data. I create a couple of objects here. This particular graph that I'm using, the line area chart, it has its X and Y are related positionally. So there's an array for this data, there's an array for this data. First one here lines up with the first one there. Since it does have the ability to do the multiple sensors, that's why it has this little JSON object in here, but the items actually go in this array here. So with that said, this loop simply takes my JSON object that I got back from the items table, or the items that I got back from my ORDS query, and splits them out into the two arrays and keeps them in sync so that they're all lined up nice and pretty. Once they're in the proper arrays, then I assign those arrays to my Knockout observable, both of them. Should anything go wrong, knock on wood, I fire up an alert that says what went wrong. And then after that function's done, I have a little set interval call here that every 5 seconds it recalls that. Is this the best way to do it? No, this is not even close to the best way to do this, but it works and it's quick and it's easier to explain. If you're not into JavaScript, this translates really well into other programming thinking. That's why I did it this way. But if you want to talk about better ways to do it, get with me afterwards. I'm sure I'll be around wherever there's whiskey. But I want you to watch this other cool feature about the grunt server when it serves it up with the built-in Node client. Okay, I'm going to just show us on that page, and hopefully I'm fast enough because it goes pretty fast. I'm going to save and then jump back, and as soon as you change your code, it watches the directory. When your files change, it does an automatic refresh for you. So you don't have to worry about your cache and all of that stuff. We can open the panel to see, yay, no bugs. I copy and pasted correctly because I'm an expert copy and paster-nator. But nothing to see because I haven't changed the HTML yet. So let's go back to the cookbook. And that's the one. And I'm going to switch over to the HTML tab. Once again, a whole bunch of HTML in here for all of the extra buttons and stuff. The only piece I actually care about is this one little div here that is the chart. So let's make that out of there. We're going to open up dashboard HTML. This right here is that little chunk of text that says, hey, put something here. So let's do that. We'll get rid of that. We'll paste in here. And this is our line area chart. So just straight from the cookbook. Since I took those buttons out, and I'd rather not receive errors, I'm going to take out the two properties that reference those buttons. So I'm going to delete those two lines. And then let me get back over here. So when I do a save, it says no data to display because it's waiting 5 seconds, and then there we go. It's showing the power usage. So I think my phone's charged enough. We can unplug that, and my computer's probably charged enough. So I'll unplug that, and then we'll wait for about a couple more seconds, and you'll hopefully... There it goes. I unplugged things because this is the live power usage that's going through all this right now. You'll notice the graph just took a big dip. Because to show you that I'm not cheating, it is actually working. And so every 5 seconds it will do that. Now we have a lot of screen real estate here, and might as well use some of it. So I'm going to go change this 500 pixels to 1,000 pixels. I'm going to hit save, go back over, it does its refresh, it waits for 5 seconds. That's a good enough time for a coffee drink. And it looks a little better. So what have we done here? Let's see if I can make my, see if I can break the projector again. One of these days I'm going to learn which pattern to make this work in. Oh, hey, we got that up. Maybe that was the pattern. Hey, it worked. That's the first time I've ever got my things to work in my slides transition. All right, so this presentation has lots and lots and lots of shiny things in there. We voided a warranty by tearing this thing apart and soldering stuff to it. Warranty probably doesn't cover me soldering stuff to their processor chip.
You didn't check?
I never check. Let's see, the only thing on this table that still has a warranty probably is my power brick and my work-issued laptop, as far as they know. But so we voided that warranty. We monkeyed with the Python code that came with the project. If you're not interested in that part, it does work just as is. We used Oracle ORDS to create a RESTful service to push our data up and to get our data from, to keep track of it in the database. We used Oracle Jet to pull that down, some little bit in JavaScript, a tiny bit of Node in there to make a pretty graph, and lots and lots of stuff. So hopefully everyone found something in all of that to pique your interest. And like I said, I would really like to encourage everyone to try something that's just outside of your comfort zone. You'll learn more that way than most other ways, and I guarantee you're going to have some fun doing it. And I love to talk about this stuff, so if you'd like to chat with me, I am available. And my name's Blaine Carter. There's my contact. Thank you for spending your time with me. Any questions? We have a couple more minutes. Come on up. Yeah. In fact, if that's done, we can tap the screen, make it come back.
Yes, Blaine, could you
Yes.
just go over again the information flow?
The information flow,
is
sure.
the database on your computer?
Oh, thank you, I forgot that. I'm actually using Oracle's Exadata Express cloud database, and that comes pre-installed with ORDS. So that's why I have that big...
That's exposed on the public internet?
It is when I tell it to be. Yeah, I had to go in and set that up. Part of that was REST enabling the service. The other part of that is you go into the Exadata Express Cloud control panel and you turn some things on in there.
So your graph program, the Jet, was running on your laptop?
No. So the second one, the one that I built, was running on my laptop. If you went to my Twitter account, that one's running on my blog site, but they're both feeding off of the cloud database's ORDS installation. So the flow of data is I plug in too many things. It goes to the power sensor. Inside of there is another radio that looks similar to this. Transmits from here to there. That goes into my Raspberry Pi, where I have Python running.
So the Raspberry Pi is Wi-Fi connected to that transmitter?
It's USB connected to the receiver. It does. It's a Pi 3, so it does have built-in Wi-Fi. If you're going to get a Pi 3. But it connects from through the Wi-Fi back up to the conference Wi-Fi. Uses Python to post the data.
Is running on the Raspberry Pi?
Yes, the Python's running on the Raspberry Pi, and it uses the ORDS. It posts data to the ORDS service that's on my Exadata Express Cloud account. And then over here, the Oracle Jet application calls a GET from there and pulls it back down to here, the exact same way it's doing on my blog. So both of those are feeding off of the same service.
So the connection you showed us in SQL Dev was to your Exadata?
Yes, the connection in there.
So when it was showing you what the URL would be for those RESTful endpoints, it said localhost. That was not true.
Okay, so an explanation there. If you use, let me do this. Let me go back to duplicate. I just learned this part myself recently anyway, so, and I have Jeff to point and holler if I do this wrong. If you go into View and you look at REST Data Services and you click on Development, you get this panel here. If I were to connect to my REST service through this, I would have the same tools that I demonstrated in the connection over here, but in this direction I'm actually going into my ORDS, and from ORDS I'm pushing back into the database the definitions of the REST services. The way that I demonstrated, I do it the other way. I come into my actual database connection and I define it over here on the database side and I push it back up to ORDS. So in that manner, the database doesn't have access to what the URI is that the admin set up on ORDS. So if you were to look at the exact same tools in the REST developer panel, it would give you the actual URI, but because it's on that server. Since I'm not on that server with this schema, it doesn't display that. But you just copy and paste it in from whatever your admin gave you. But both tools actually work almost identically as far as all of the setup and the configuration. And you can even do that pure PL SQL. Just put it in the worksheet. And so if we were to look here, oh, where did it go? How do I get to the SQL from here, Jeff? I'm in the SQL for defining the get statement. No, that's a... Oh, let me close that. Let me get back to there. So right click on usage.
I'm sorry, on the power.
On power.
Say that export.
Oh yeah, I'm on an older version. Because I was looking for that. I'm on an older version of SQL Developer. My Linux version is newer. Right there you would see export here. And it would give you a script that looks like... That's not sexport, that's ORDS export. So this is what it would look like. If you want to hand make a REST service just typing in PL SQL, this is exactly what it would look like to define both of those services manually. I keep this so in case I crash everything else, I can quick fire this and run a VM. But this is what the SQL looks like when you do the export.
Quick question.
Yes.
Without opening up that box, could you have created a Twitter account that you're going to use for pass-through and just access Twitter's API to sort of aggregate that data and then push that up to...
Which box? This one?
The power, yeah.
Well, the transmitter, you have to, if you're going to do the project, the transmitter is in here, so the only way to access the data in here is to open it up and solder in the piece. At that point, it transmits from here to this one, and then the Python code that's running on the Raspberry Pi, it has a section that sends it to the Twitter account, and you would put your credentials in the Python code of the Raspberry Pi. And you can also run that over here. When I was in Cleveland, I ran that graph that's on my blog on the Pi, and I tweeted that out. Apparently that's a bad idea. Everything went, so I had to tap dance while I moved everything over to my laptop to get it back up and running. So, but I'll be here all week if you guys want to talk about this stuff. I have a couple other projects that are kind of fun, but thank you very much.